The universe is full of fascinating objects. Some we know, many we don't. But in the late 1960s, we were successful in discovering the smallest and the densest stellar object called neutron stars. So what are neutron stars? And how are they formed? Well, let's understand that in this video. A neutron star is the collapsed core of a massive supergiant star which had a total mass between 10 to 25 times the mass of our Sun. Even though neutron stars have a very small radius as compared to the Sun, they are almost 1.4 times heavier. Once formed, a neutron star no longer actively generates heat and cools down over time. However, they may still evolve further through collision or accretion. Neutron stars are formed when a massive star runs out of fuel and collapses. A star combines hydrogen atoms in its core by a process called nuclear fusion, which releases a tremendous amount of heat. The force created by this fusion reaction balances the gravitational pressure experienced by the star due to its mass. Now, as long as there is hydrogen present in the core to fuse, the star continues to remain stable. But as the hydrogen reserves are limited, eventually the core runs out of hydrogen and the star collapses violently, erupting in a supernova explosion. This supernova explosion, combined with the gravitational collapse, compresses the core to a density of an atomic nucleus. As a result, a neutron star is formed. Neutron stars that can be observed are very hot and typically have a surface temperature of around 600,000 Kelvin. Now the temperature inside a newly formed neutron star ranges from 10 raised to 11 to 10 raised to 12 kelvins. However, due to the huge amount of radiation losses, the temperature of an isolated neutron star falls to 10 raised to 6 kelvins within few years. The density of a neutron star is so high that 1 teaspoon, which is 5 milliliters of its material, would have a mass over 5.5 into 10 raised to 12 kg, which is about 900 times the mass of the Great Pyramid of Giza. Their magnetic fields are 10 raised to 8 to 10 raised to 15 times stronger than Earth's magnetic field, and the gravitational field at the neutron star's surface is about 200 billion times that of Earth's. Many neutron stars are undetectable because they simply do not emit enough radiation. But some are found spinning wildly with extreme magnetic field as pulsars or magnetars. Pulsars are rotating neutron stars that are observed to have pulses of radiation at regular intervals that typically range from milliseconds to seconds. They have very strong magnetic fields which funnels out jets of particles along the two magnetic poles. These accelerated particles produce very powerful beams of light. Now when this beam crosses our line of sight, we see a pulse. In other words, we see pulsars turn on and off as the beam sweeps over Earth. Another type of neutron star is called a magnetar. Now a typical neutron star has a magnetic field that is 10 raised to 8 to 10 raised to 15 times stronger than that of the Earth's. However, in a magnetar, the magnetic field is another 1000 times more stronger than a neutron star. In all neutron stars, the crust of the star is locked together with the magnetic field, so any change in one affects the other. Thus, in a magnetar with its huge magnetic field, movements in its crust will cause the neutron star to release a vast amount of energy in the form of electromagnetic radiation. Well, that was a brief information about the neutron stars. I hope that this video helped you to understand this stellar object. Now, if you wish to know more about pulsars and magnetars, then I have made separate videos explaining each of them in much detail. You can watch them by clicking on the card appearing in the top right corner of your screen. If you have any thoughts and suggestions about this video, please feel free to put down your comments below. Also, don't forget to like, share and subscribe and ring the bell icon to stay notified. Thank you for watching. See you soon with a new video.